Talk a little bit about setup here of this part. Now I chucked it in the chuck and I put some packing between the hard jaws so that they didn't make marks on the part. And that's all running true down here. And on this end, I didn't have a plug to fit in this part, but I had this little 3-jaw chuck that I've made. I made a mount to run on the tail center, so this clamps on the tailstock. The tailstock on this machine, by the way, has bearings in it, so it's a live center arrangement in the quill. So you don't have to put a live center in the tailstock itself because it is a live center. And this thing clamps on the center part of it, the OD of it. And this is a little 6-inch 3-jaw chuck that I had. And I just, if you can see it here, I don't know if you can see it, but I welded on these pieces on these jaws, these soft jaws that I already had for the chuck to extend it out. Then I clamped something in the turning spindle on this end, a bar, and I clamped it in the chuck to turn this, because this is just a live center. It's not, this here is just a live center. It's not, it doesn't have any ability to rotate on its own without something turning it. So I chucked onto that with the little chuck here on the steps that are already bored in the jaw, and I turned a shoulder on here to grab onto the ID of this tubular part. So that gets me supported out here on the end, which wouldn't be that important for the turning part, because the turning part, you know, it might even support itself down there. But when I start to mill out these slots in here, this is not gonna, you know, it vibrate too much. So that's basically the setup. And then we have these holes that are already in the part that have to be clocked in such a way. So we had to set our C0 is up here actually, but this is 90 degrees. So I indicated one of these holes and then set my C0 90 degrees over like this. And that's just the way I have it positioned in the CAM software. So that's why I need to do it that way. So that's the basic setup here. And now we're going to turn this OD down to size. And the thing that's going to give a little trouble with that is these holes here, because this whole step is going to be roughed off back to here somewhere, and then and down a little bit smaller in diameter here. And turning through the holes like this is always a difficult thing on the turning tool, so I took shallower depths of cut. I could have taken, you know, maybe 1/4 inch depth of cut, but because of these holes, I have found that tends to make the tool, the insert, fail. So I reduced it to about, I think, 100 thousandths or something like that. I'd have to look at the program, but and that seems to help a little bit. And I might even have to slow the feed rate down as I go through these, just manually at the control, because this always gives trouble, this intermittent cut with holes like this in the part. This is just steel, so it's not as bad as some exotic metal, but it always gives some trouble. Let's look at the CAM software, the simulation in the CAM software. This is in Esprit TNG, so we can kind of see what's happening. The customer provided me with both models, so it's kind of convenient. I could actually use what the original part looked like and then the new part to simulate with here, so it's kind of nice. Okay, let me just run the simulation and we can see what's happening here. Okay, this is the turning operation, obviously. Speed it up a little bit here. And you're going to see all this in the video, the actual machining. I just wanted to show you this so you can kind of get an idea of what's going to go on here, and maybe explain a little bit about why I chose certain things that I did, the strategies. There's the finish tool. Now these milling strategies, I chose them because, let me pause this a little bit and I'm going to make the stock so you can see it a little better here. I chose these strategies because I'm going to be machining this kind of unattended. I'm going to be over there running the other machine, and so I wanted to just mill all this material away. Now, it would be possible, I suppose, to mill a profile around and just break out the middle. But you see this rib thing in the middle of the part? It kind of creates an inconvenience, and the two bores are two different diameters. So I just decided I'll just mill all the material away into shavings. That way I won't have a slug dropping in the middle of the tube or something and possibly damaging the end mill when it does that. So this is what Esprit calls their profit milling cycle. I think Fusion calls it adaptive milling. It's sort of a mixture of tricoidal and profile milling. In my opinion, this isn't the most efficient way to mill something, and in this particular case, it's even less efficient because I'm taking small radial depths of cut just to make it more reliable, so I don't have to worry about it when I'm over here at the horizontal mill, and that's machining over there at the Mazak. I don't have to be concerned that it's going to be breaking the tool or like I said, dropping a slug of metal out into the middle of the part or into the tool and causing a problem. So it roughs the first side of all these notches or cutouts, if you will, and then it goes around the back side. I'm going to hide the various, if I could do it correctly, things on the machine here so we can see the back side, so I can rotate the simulation around. Otherwise you're just looking at the back of the machine. So that's the third slot, pocket, whatever you want to call it. These are actually pockets. Now it would be possible, I suppose, to do like a 5-axis profile around this, but I didn't want to get to all that trouble to do it. And in essence, it doesn't help me mill all the material away. So let's look at this on the other side. This is the back side. And I got this little slug here that has to drop off, which that did that okay. So didn't really have a problem with that. As you'll see in the video, I started with this old end mill and I roughed everything, and then I changed to a different tool to finish it with, trying to use the tooling I already had on hand rather than having to use something new. So here's the finished cuts. You really can't see it's kind of hard because they're so shallow. And then the finished cuts on the back side. So that's the basic machining operation. All right, here's the turning operation. I come in with the CNMG 432 insert on this tool. Now, after doing this, it would have been better to run a tool with a lead angle so that when I approach those holes, that intermittent cut, I would have had less trouble. But I just wanted to get through this part, so this is the way I ran the program. Just for one part, it wouldn't make too much difference. Although I did run into a little bit of trouble later. But what I was doing was when I intersected the holes with the roughing tool, I slowed the feed rate down manually just with the override buttons on the control to about 40% of what I was actually doing. I think I had a 16,000 speed per revolution, and I was slowing it down to about 5 thousandths where it was intersecting those holes. And that seemed to be working all right for the most part. I think later you'll see I did break an insert, but I think it was because I was running coolant on the tool when I was doing that, and that kind of is not really the best thing to do. If you have an intermittent cut, it's better not to have coolant, because it kind of, the insert gets hot in the cut, and then between, when it's not cutting anything, the coolant cools it off, and it can kind of fracture the carbide in that situation. So you can see those kind of lines on the OD of the part there. That's where I'm slowing the feed rate down when it goes through there, and then speed it back up. And those flashes of light are from me shining a flashlight through the window there. I was trying to run as much of this as I could without coolant so it would be clearer on the video. A little bit later, the part was getting kind of hot, so I started running coolant, but like I said before, I think that's what caused me to break an insert in one of those holes. Or maybe it's just that I didn't catch it fast enough to slow it down. Could have been that too, because I have to wait until I hear it hitting the hole and then I'm slowing it down. Here's where I broke that insert right there, and I had to index it. When I took it out, the insert was broken in half practically. It kind of got a little bit, it chipped the key, the seat I should say, underneath the insert a little, but it wasn't bad enough to have to change it right now anyway. So for the remaining of the roughing, I ran it without coolant. I think that helped a little bit with it not breaking the insert in those holes. But it did leave kind of a gouge in the OD, but fortunately it was on the second to the last pass on the roughing tool, so it still had material to come off, and that cleaned up all right. But you sure don't want to break an insert right before the last pass, right before the finishing tool, because that can put a gouge in the OD of the part. You can see it real clearly that now. See that ring in the part where the insert broke. So this is the last roughing pass, so I was being kind of extra careful here. Slowing the feed rate down. You can see the shavings kind of ball up there because the insert doesn't break them properly. When I slow the feed down, that's to 5 thousandths per revolution. I think I was running about, on the roughing tool, I was running about, I don't know, it's 450, 500 surface footage, something like that. 16 thousandths feed per revolution. I was slowing it down to 5 thousandths per revolution where those holes were manually with the feed override buttons on the control. So this is the last pass. I think on the finish tool I ran about 900 surface footage on the finish tool and 5 thousandths feed per revolution. Here I'm just going to start with a fresh tip on the insert. I'm just going to cut a little ways in here and mic it with the mics just to see that I'm not totally out of whack with my tool offset or something. And it measured right where I thought it should, so I restarted the tool and ran the tool. Although I think I offset my roughing tool out just to be safe, and I had kind of too deep of a finish cut here. Even though I'm standing off, I had too much material coming off, and it caused this problem with the shavings. So I had to stop it there. I was worried about them balling up and hitting the camera and pulling it into the chip pan, so otherwise I probably could have let it go, but I didn't want the camera to get messed up. So this is sort of the rough finish pass. I mic'd the part, and it was just where I thought it should be. I had set the offset 0.010 of an inch out, and it was exactly that. So I reran the tool. Now you can see the shavings have a little bit more control over themselves. It's taking too deep of a cut with the finish tool the first time. So that's the turning work, a very simple turning job. I'm going to start the milling next. We're going to try this tool. This is an old worn end mill. I've got a new one, but I'd just as soon do this with the old one if I could do it. It's nothing real critical. We're just going to mill some slots in here. And so hopefully this tool will do it. And I don't have to use the new one. Here we are. We've roughed out the first notch on all 4 cutouts. Now we got to come in from this side actually and rough down this way, coming in the back side, if you will. And I'm not sure my end mill up here, it's getting a little bit tired. I'm going to try and see if I can do it with that one, but I might have to change to the newer one. This was a lot of material to rough out. And this is, you may have noticed from the video, this is going kind of what I would term slow. And I was going to explain this when I show you the CAD model, if I haven't already showed it in the video. I don't know. I'm kind of filming this before I did the CAD model stuff, but this I wanted to run this unattended kind of. I'm running the other machine, the horizontal mill, on the titanium parts, and I just want to let this sit and run. I didn't want to have to be concerned with, is it gonna, screw up or something, or is it something gonna happen, and I have to be over here watching it real carefully. So I've programmed this to run very conservatively taking small depths of cuts, just going back and forth like you see in the video. But it could be done faster, but because of this area right here, see if I can show you this here, if I can position the camera. See this ring inside the part here is part of the issue. Otherwise you could just mill this pocket out, but if you have this little section here supporting this whole big drop of material, it's going to vibrate and everything out here, and it's not going to work right. Now I could have come in here and just machined these areas through and then profiled out the piece as well, but if I'm not sitting here at the machine watching it very carefully, it could drop in such a way as to damage the end mill or even break the end mill I'm going through here with, because you got to be ready here to catch the drop kind of, or push it away. And I can't really do that on the Mazak here either, because the doors close and you can't get to anything with these doors closed on this machine. It just has interlocks and you can't run the machine with the doors open or reach in here with a stick or something and push on that drop and that chunk that's going to be falling out of the middle here. So the safest way I've determined, because I want to be over there running the other machine, is to just mill it all away. And so that's what I'm doing here. But this, this kind of takes a lot of time and a little cuts here, but I didn't, like I said, I didn't want to have trouble with the tool, and I wanted to just let it run by itself over here without anybody watching over it. So it's programmed very conservatively. I could have taken deeper depths of cuts, and also I'm starting with this end mill I've been using. This in the tool here is like an old end mill I've had around here for ages, and I was just trying to get through this part without having to buy some expensive tooling if I could do it. So that's kind of the reasoning behind this whole actual program and setup. I know in the comments on this video I'll get people commenting, "Oh man, you're taking forever," or "That's such an inefficient way to do it," and all that. But they don't know the whole situation here and what I'm trying to do with running another machine that's, I'm looking over there, the horizontal mill's probably 100 feet away from this machine, so I might not be able to hear what's happening over here when I'm over there running that machine very well. So I know everybody's an expert, but this is the easiest way for me to do it and not have to be sitting here right at the machine, ready to stop it if something goes wrong. If I just machine away all this stock here and it just falls away as shavings, it's just a lot safer situation for me to do. It's not efficient at all. By no means do I even recommend doing this. If you had a lot of these to do, I wouldn't do it at all this way, but I just got the one part, and I can just let it sit here and run while I'm over there watching the other machine. I kind of blew that part off and I knocked off the major burrs. off the OD. You know, there's spurs here. And now we do the finish cuts. Now the end mill that I used to rough this all out with is pretty well worn out. So I don't really want to use the same tool for finish cutting. I think what I'm going to do is change to a 4-flute tool too. I don't know if you can hear that, but maybe you can hear it like that. When I finished roughing this, the last cuts in here, when it was cutting down at this end, sounded like they kind of wanted to chatter a little bit. And I think what I'm going to do is change. I have this tool I've got in the spindle that I was roughing it with up here is a 5-flute end mill, kind of a high helix 5-flute thing. And I think I'm going to go with a 4-flute end mill to do the finish cuts on here, because it'll have less of a tendency to vibrate. There's when you're cutting with end mills, the more flutes you have, the more flutes are in contact with the work at one time, and so it'll tend to put more force on the work and the tool and tend to chatter more than fewer flutes. Like a 2-flute end mill would chatter less than a 3-flute, and a 3-flute less than a 4-flute, and so on. So I think I've got a 3/4 inch 4-flute of the appropriate size. And I think what I'm going to do is swap it out with this tool out here, and we're going to take the finish cuts with that. I got to alter the program slightly, maybe change some feeds and speeds a little bit. I think I'm going to slow the RPM down too, because I'm kind of concerned about a vibration down at this end. Alright, the finish cuts are done. One thing left now is to do some deburr. Polish this out a little bit. There's a little bit of overlap in the cuts here. Scotch-Brite wheel will take care of that. It did chatter just a little in the corners here. It'd be easy to polish that out here. I don't know if you can see it. There's a little bit of chatter in this corner, mostly here. The only end mill I had had a big tip radius on it, so I'm gonna have to file and polish this out a little bit, because it didn't quite overlap because of the tip radius right there on these spaces. Did okay over here though. These corners seem to be all right. No big deal. Could hit that with the file and then a Scotch-Brite wheel on the angle grinder. I'll have to hit it in here a little bit. I don't know if you can see. Anyway,